recording this for the absent children. See how loud I can be. I don't have the directions on this one, but the first one you're just supposed to state the vertex on the axis of symmetry, and it's already in vertex form, so just a reminder that this is H and this is K, so you should say, I'm just going to sit down over here. It's not working. The vertex is H and K, so you would say the ordered pair 5, -7. Opposite sign of the inside, same sign as the outside. And I think it asked you for the axis of symmetry. The axis of symmetry is x equals h, so that would be x equals 5. Yes? That's great, right? The one on your test is more like number 7, where you have to put it in quadratic form, which means you have to put these two together and factor out that -2 first. So if we factor out the -2, we'd be left with x squared plus 8x. Remember, you don't have to factor it out of the last term because we kicked that -31 out here, right? You have an exact problem like this on your test tomorrow. I mean Monday. And then we complete the square. Half of 8 is 4, and 4 squared is 16. So we add 16 here. And remember, if we add it on the inside, then we subtract it on the outside. But don't forget, you have to multiply by that number in front also. So you're actually subtracting 16 times -2, which is adding 32. So to put that in quadratic form would be f of x equals -2. And then you should be able to write this as the perfect square. And it's half of that middle number, so I think it should be x plus 4. And then make sure you can do this all at once on your calculator if you want. Or you can just do -16 times -2 is 32. -31 plus 32 is plus 1, I think. So then your vertex would be -4, +1. How fun is it going to be for me to graph over here? We use my mouse. That's going to be awesome. It's not bad until it just like takes it and like makes a big line, which is part of my issue right now with my smartboard that it's doing. But it's alright. It's annoying, but there's also a question like number 10, which we did on our homework. I did it on the board after I assigned it to you on the homework. I had it on a homework quiz. We did it on a worksheet. 4th time, there is going to be a question just like number 10. Put this in vertex form. You do not do slope when you're talking about a quadratic, right? It's y equals a times x minus h squared plus k. No slope involved, but your vertex is h and k. They give you a point because you have to find what a is. We don't know what it is, but you can plug in your x and you can plug in your y. So I'm looking for the fact tomorrow, Monday I mean, that you plug in y for y, so that would be -2 equals a times x, which is 3, minus h, which is the x of your vertex, minus -1 is going to make that +1, and k is 1. Now you just got to solve that for a. I could subtract 1 over. I'm going to come over here. So I would get -3 equals 3 plus 1 is 4 squared. So I think that would be 16a. So divide by 16, and you get that a equals -3 over 16. Just like when you write a linear equation, you find your slope, you plug it in, you find b. You're not done when you find a. You have to write the equation. So the answer to this would be the equation y equals -3 over 16 times x minus -1, so that'd be +1 squared plus 1. Write the equation in vertex form that has a vertex of this and a point like this. 25 and 26? How about I tell you the answer, and then you tell me if you still want me to work it out? Does that sound like a good plan? Because I can work it out if you want, but if you don't want, then I'm not going to work it out. Oh, of course, it's not even in here. I hope you checked your answers in the back, did you? It's a smart thing to do. 25, how about I just write this? 25, the answer is 2x squared minus x plus 1 minus 2 over x minus 3. You need me to work that out? Yes? No? Yes? On your test, I'm going to make you do one long division, one synthetic division. So, Taylor, which way did you do this? So if you do long division, that's going to be fun to do. And make sure you read the directions on your test, because I really think there's one that just says use long division to give me the remainder, which means I just want the remainder. But this one is actually working it out. So what do you multiply x by to get 2x cubed? You get 2x squared. You multiply that down here, and you get 2x cubed minus 6x squared. The biggest mistake on this is subtraction. I put my subtraction sign all the way through, so I would get negative 1x squared, bring down my other number, which is plus 4x. Girls, you okay back there? I'm expecting A pluses if you're having too much fun back there to make sure that you're good on these. Oh, okay. Just making sure. I can do synthetic division also. I'll do synthetic division on this one. I think doing my math right here, I would get x minus 5. Oh. I'll just use a chalkboard here, kids. So then plus 1. So then you get x minus 3. But when you subtract, you change that to addition, so you get a remainder of negative 2. If the question just said use long division to give me the remainder, you'd still do all of this, but your answer would just be negative 2, right? But this one, it actually says divide it, so I'm going to write minus 2 over x minus 3. Most of the time, if you miss something, it's just a subtraction issue. Yes?
Okay, so I think where I messed up at is in the negative 7 minus 26. Because when I took that on my calculator, I couldn't. So I thought, like, you can do that, but it has, like,
When I took
plus.
2 times negative 3 is negative 6, but you're subtracting, so you're subtracting a negative, which is a positive, right?
Yeah, but wouldn't you add that to the solution? It's over there.
Yes. 26. Let me just work that. I'm going to do I'm going to do synthetic division on this one. I would divide by negative 2, 1, 3, 1, negative 3, 3. If I bring that down, I would have negative 2, add and have 1, and then that's going to be negative 2, and then negative 1, and then 2, and then negative 1. And then they're all 1s. And then 2, and oh, that's not negative 1 at the end. 5. It was so close to being all 1s. Only I could get enjoyment out of that problem. And then you just write 1 less, right? So x cubed plus x squared minus x minus 1. Your remainder, add that, right? Some people just like put that 5 out there. You actually add your remainder to what's left. So plus 5 over what you divided by, which is x plus 2. And those are just, take your time on them. If you make a mistake, hopefully it's just a small little negative sign mistake. Like if you got the wrong thing here, yes, it's going to affect your answer, but if I see that's the only thing you missed, you're only going to miss 1 point. Okay? Use the remainder theorem to see what the remainder is. Check by using synthetic division. So all you do on this one is use the remainder theorem. That means they wanted you to just plug -2 in here, right? Which means you just use your calculator. 3 times -2 to the third minus 2 times -2 squared plus -2 minus 5, and that right there is the answer. You should get -39. Did you get that if you did that? It says check by using synthetic division. It's okay if you did. That just means when you do synthetic division, you should also get a remainder of -39. But if I say use the remainder theorem, that means you just plug it in. Like, that's why we love the remainder theorem. How about 31 and 32? You have questions just like 31 and 32 on your test, except I add extra directions. It says, use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. And then my test says, if so, find the remaining factors. So like on 31, when you divide out 2, 1, -4, 8, -8, you should get a remainder of 0, which means if you get a remainder of 0, you say yes. But on the test, it says, if yes, find the remaining factors. And that's like what was on the bottom of that worksheet yesterday, which I have graded for you. But that means you take what's left, x squared minus 2x plus 4. And if you can factor it, then you factor it. If you can't factor it, then you just leave it like that, and that would be your answer. Can I factor this? Multiplies to give me 4, that adds to give me -2. That's not factorable. So if it's not factorable, just tell me what's left over, all right? So if it's a factor, find the remaining factors. That's what that means to do. And on this one, when you divide it out, it doesn't work. So you just get to say, no, it's not a factor, and you don't have to do any more. Do you want me to work that one out? So if I divide that out, I divide by -3, 1, 2, -4, -2. Yes?
Okay, going back. What is the, just write it in the equation, and then how do you determine if it's a factor or not?
On 31?
Yeah.
To determine if it's a factor, right, determine whether the first polynomial is a factor of the second. If you get a remainder of 0, then it is a factor. Yes?
Yeah.
The extra part is find the remaining factors. And since I want you to write them as factors, if you can factor it, factor what's left. But on this one, since it's not factorable, you would leave it like that. Does that make sense? That's just the answer. If what you had left, let's say on the test, you divided it out and you were left with something like this. X squared minus 7x plus 10. Let's say that's what's left after you divide it. If you can factor that, give me the other factors that factors into, right? So like you could factor this into x and x. 5 times 2 is 10. Subtract, subtract. That would be the other factors if it's factorable. No, because I want them as factors, not zeros, that's why you don't have to set them equal to 0. Does that make sense? And so you'd leave it like that. If it's not factorable, you leave it like this. Yes, dear. Oh, you just plugged it in? Yeah, that's totally fine. The only reason I did like this is because I'm thinking ahead to the test, whereas if you get a remainder of 0, you want to divide it out. So that's why I did it. But yes, if you just plug it in and get 0 and say yes, that's okay too. I wasn't. For me, it's faster for me to do synthetic division than to get a calculator out and plug that in, because I don't have one on me. But yes, that's a valid way to do this as well. But on this one, whichever way you do it, you get a remainder of 1. So since it's not 0, you say no and you move on. You don't get to factor what's left because it's not a factor. Okay? That's good stuff. Question just like this on the test, and it's just practicing or seeing if you know the rules for upper bounds. If it's an upper bound, when you divide it out, what is left better just be all positive or 0, because 0 counts either way. And if it works, you say yes. If it doesn't work, you say no. Well, if I gotta click back on this, this is the most annoying thing ever. So you get 0 here, and then 25, and then 28, and then I don't know what that is, but it's big and it's positive, and that means that's going to be positive too, right? Trust me on that? Positive, positive. So since these are all positive, this is a positive number, we can say, prove that the number is an upper bound. Then we would say yes, 5 is, what? Oh my goodness, thanks. Either way it still works, right? But yes, you're right. That should be 3, and that should be, oh, that makes my math so much easier, and that would be 19. Thanks, kids. Upper bound. Thanks. Sometimes I don't know how to multiply. I'm just so concerned about this mouse issue. I'm going to blame it on that. Thank you. Either way, it still worked. I didn't screw that up too bad. Lower bound, did this one work when you divided it out? 2, 6, 1, negative 6. Let's see. This one should be alternating. The tricky part about this one is we get a 0 here, right? But if you look back at how we wrote that out, a 0 counts either way. So positive, nothing, positive, negative, this counts as whichever you need it to be. So that actually is a little bit tricky there, but it does actually work because 0 counts either way that you need it to count. Just like on the positive one, 0 counts as positive. So yeah, we would say yes on this one. There's one question on your test like that, so I don't remember which one I gave you, whether the positive or the negative, but it's just checking and showing that you know that to do synthetic division. Write a list of all PRZs, then determine which ones, if any, are zeros. Factors of 6, so that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Over factors of 2, plus or minus 1, plus or minus 2. So I would want, not that. How about I just say them? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 3/2. I think that's everything, isn't it? And then says find which ones, if any, work. On the test, there's not going to be a huge amount to check, so then you just have to check them. And I think 2 works, right? So it's up to you on how you want to do this. If it just says find which ones work, you could just check all of them, and whichever ones work, those are your answer. For me, if I found that 2 worked, I would divide it out and then see if I could factor what's left, because I hate checking these numbers. Probably one of my least favorite things we do all year. I'd rather graph than check these awful numbers. So for me, I'm going to do it like this. That's not negative 6, that's positive 6. 2, 4, 3, 6. Right? I can do that much faster than I can keep checking numbers. And so then, oh, the bad part about this is a cubic, isn't it? Plus 3x squared plus 2x plus 3. But that's factorable by grouping, which means you could keep checking more points. It's actually, I think, 3/2, or no, negative 3/2 is what ends up working. And again, if you checked a bunch already and you don't have many left to check, check all of them. But pay attention. If you notice that that's factorable, to me, I can factor that. I can factor an x squared out of it, and I'd be left with 2x plus 3. And this one, I'm going to factor a 1 out of it, so that I'll be left with 2x plus 3. Oh, that's disappointing. And that's how I'm going to get my other factor. Because I can factor that as 2x plus 3 and x squared plus 1. And set both of those equal to 0. So this one, I get my negative 3/2, and I didn't have to pick any fractions by plugging them in. And this one I'm not going to solve because it's not real, and I only want real numbers. Alright, so x equals negative 3/2. Don't forget to give me the one that worked already. X equals 2. If you don't circle that and tell me that's an answer, then you're going to miss a point on that. 38's awful. Did you work that one out? Your PRZ's factors of 7 over factors of 6, so there's a lot of fractions on that one. Plus or minus 1, plus or minus 7, and then over factors of 6 gives you plus or minus 1/2, plus or minus 7/2 plus or minus 1/3 plus or minus 7/3 plus or minus 1/6 plus or minus, oh wait, is that it? That's it. Oh, 7/6. I wouldn't give you one like that on your test because that's a whole lot of fractions to check. But if you did do that one, I got, actually I didn't get, the book got 7/3 as the only one that worked. Did anybody find that to work? Even one, you had to check a lot. 7/3 works, and again, if you don't check them all, the smart thing to do on this is divide it out, and I'll even show you if I divide it out. 6, -20, 11, and 7. 6 times 7/3 is going to be 14, and then that would be -6, and that would be -14, and then that would be -3, and that would be -7. Right? What's left, if it's not factorable, then it's not rational, so you don't have to go any further. And so what's left on this one is 6x squared minus 6x minus 3. You can divide everything by 3, so you get 3x squared minus, not 3, sorry, that would be a 2, right? 2x squared minus 2x minus 1. And you could do the quadratic formula, you could try to factor it, and it's not going to be factorable. What multiplies to give you -2, that subtracts to give you -2 is nothing. So that's not rational, so you don't have to go any further. I like dividing it out, because you have to on the real ones anyway. Did I give you one that says find the real ones or not? Maybe? We'll see. I don't know what's next. I'm going on. I didn't. If the direction said find the real zeros, if this said find the real zeros, you would have to try to solve it, and if you got something other than an imaginary number, you'd have to do it, right? Like, you'd have to give me that radical, and we did a few like that. We did this one on our homework. If you actually went back to your homework, I think this is the exact same one that we did, but I gave you this one because there's one like this on your test. So I want to make sure that you remember all you have to do is put this in vertex form, and the H and K gives you the answer to B and C. So it says, they threw, okay, maybe we didn't do this one. Competition is held to see who can throw a baseball the highest from the front row of the upper deck of seats 83 feet above field level. The winner throws the ball with an initial vertical velocity of 92 feet per second, and it lands in the infield grass. Remember that equation I gave you? We used it last chapter too. It's -16 t squared plus v sub 0 t plus s sub 0, where v is your initial velocity, s is your initial height. And so you can write the quadratic equation because they tell us that the winner throws the ball with a velocity of 92 feet per second. Like, it almost pointed right to where it should go. 92 t. And they started 83 feet above field level. So that would be plus 83 out here. Sorry, I guess it's A and B on this. Find the height of the ball and how much time it's in the air. That means we want to find the maximum height is going to always be the vertex. And so all you have to do is complete the square to put this in vertex form. And your H is going to be your time, and your K is going to be your height. Right? Remember doing this? Vague memories of this? Does 92 going to 16 going to 92? Oh, not so nice. So this one's a lot uglier than the one that we did in class, but complete the square, we could factor out the -16, and we would have t squared minus, what's 92 over 16, -16. I'm just going to divide that out. It's like 5 point something, but I'm a fraction person, so I'm going to write that as -23 over 4t. Right? That's taking the 16 out of the 92. Good news is I don't have to take it out of that 83 out there. If you want to use a decimal, use a decimal. I promise, because it's a story problem, the decimals work out really nice, but I just do better with my fractions. To take half of 23/4 would be like multiplying by a half, so that would be 23/8. Oh, this is so ugly. And then I'm going to square that, so that's 23 squared, which is 529, over 8 squared, which is 64. And if I add that on the inside, I have to subtract it on the outside. I'm not erasing that. 64. But I also have to multiply by that negative 16 out there. We did one like this on the worksheet I passed back to you. It was like on the back page of the worksheet. We did it together in class. And it was kind of ugly big numbers like this that you could go back and look at for another example. Because this is on your test. So what is this? Negative 16, and then that's t squared minus, sorry, just kidding. It's not t squared, right? If I'm going to write it as a perfect square. It's t minus something squared. How do I get that something right there? Half of that, right? I think that was 23 over 8. Is that right? This, I'm going to just do this all in my calculator at once. I'm going to type in 83 minus 529 divided by 64 times negative 16. And I get positive 215.25. Did I do that right? This is your vertex. Yes. 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 Deborah, you're leaving to the office. I get that to be a vertex of 2.875, comma 215.25. Is that correct? That means this is how long it took. So when it says how many seconds did it take to reach the maximum height, a little bit under 3 seconds. And how high did it go? This is your height. So I promise that there's a question like this on your test. So make sure whether you go back and redo this one, whether you go back to section 2.1 notes, we did an example like this, we did one on a worksheet. Go back and try one of those, or at least make sure you're aware of what to do, because that's probably about a 5 or 6 point question. You got to complete the square. Yes.
Is it gonna be like this?
Like it might not be so pretty. Maybe. Yes.
So, okay, how would you use this part C?
Oh yeah. I don't know.
What do you know?
I don't know. Determine its vertical velocity. I feel like I know how to do it using calculus, because we do this in calculus all the time, but I don't know how to. I don't know. I have to cheat. No. You don't have to part C. Sorry. Vertical velocity. I don't know. In calculus, velocity is the derivative of this, so we could just take the derivative, and then we could set the derivative equal to 0, and then we could solve it, but I don't know how to do it without calculus, so obviously there's a way to do it, but that's alright. You know, I thought we could do this. Determine the velocity when it hits the ground. We could figure out how much time it takes to hit the ground, plug that in for t, and the height would be 0, so we'd set it equal to 0, and we'd have to solve for v, maybe. No? I don't know. I'm making that up. Let's just not do part C. Part A and B is what you're going to have on your test. Alright. The other two are graphing ones. I think one of them maybe we did in our homework already. We're probably only going to have time for one of these. But just like the one on your worksheet from yesterday that I'm going to pass back to you in a second, you might have to factor it first, right? Like both of these are factored out, but like on the one on your worksheet that was x cubed minus 9x, right? You could factor an x out of that and you could do that one. But you got to be able to give me like the multiplicity. So I don't know. I feel like 41 is worse than 39. You want me to do 41? You want me to do 39? So 41. I want you to use the in behavior, the zeros, the multiplicity, all that stuff, and that's what the directions will say on the test. But like right away, what would the degree of 41 be if we worked it out? Yeah, it would be x to the 5th, which means it's odd and positive, which means my arrows should look like this when I'm done, right? This side should go up, this side should go down. On the graphing ones, you don't actually have to write out the end behavior. You can just use that to help you. We can find our zeros. Could you imagine if I had to deal with this every day? I might just start using the chalkboard. My zeros are x equals 1 and x equals negative 2. The multiplicity tells me it's multiplicity, but it also tells me whether it crosses or touches. So since that's a 3, I know that it has a multiplicity of 3, and because it's odd, I know it crosses. This one has an even multiplicity. I would say that has a multiplicity of 2. Isn't it weird how it always takes it to the same spot? Why does it do that? And because it's even, that means it touches at that point. That's about all you can get from the stuff that we know. XY chart is what you're going to have to do at some point. But I like to graph my zeros and then kind of think about what points I need to pick. This is awful. That's all right. That's all I'm doing. I'm just going to wing it from here. But graph my zeros at 1 and at negative 2. You need to pick the numbers that occur between your zeros. So make a little XY chart. And if we plug in 0 for x, you can use your calculator, but that's going to be negative 1 times 4, which I think is negative 4. Is that right? Oh, look at me doing so good at putting 4 marks down here. And then I'm also going to plug in negative 1 to see what's happening. And if I put a negative 1 there, I would get negative 2 to the 3rd, which is negative 8, times just 1. So that's negative 8. 4, I'm just going to kind of wing that and pretend that's down here. That's about right. And then if you want to pick the numbers, like each number right beside your zeros, that totally is fine with me. That's going to give you a really accurate graph. But you can also use the end behavior to help you. Negative 2 just touches, which means I know that this side, I know that this comes down like this, right? But since it just touches, I know that it needs to turn and go back the other way. I think that should look a little better than that. I think it should look more like this. Oh, that looks so much better. Let's erase that. Right? So I don't even actually have to really pick the point because I know my end behavior. But if you want to pick it, there's nothing wrong with it. And then what about this one? This one I know there's a multiplicity of 3. That means it should kind of look like that x cubed when you graph it. If you want, pick a point and see what's going to happen. But I'm just going to kind of... that really wasn't so good, but... How can I make that look worse, kids? I'll fix it. I'll try again. Show me something that there's a multiplicity, right? Don't just draw a straight line. So, like, maybe I can go... Oh, look, that looks much better. You make that little noise when you're drawing it, it helps. So, even multiplicity touches. If it has an odd multiplicity of 3, then it should look kind of S-ish. I'm looking for some work on that, not just a graph. So show me this stuff over here too. All right. 39, I'm pretty sure we did in our homework already. If you go back to section 2.1, like it's a homework problem, but it's also in the back of the book. If you haven't done it, there you go. That's the only review problem I didn't do for you just now. I'm exhausted, and I sat here the whole time. That was insane. Your test is on Monday. All of your chapter 2 homework is due on Monday, so make sure you bring that. And then our test is just going to take 1 day, so make sure you come ready. Practice that vertex form problem. I think that's probably the hardest question. Okay, but that's it. No new homework, but that means you have to study, which means you should take your book home, right, Bryce? Yeah. If you're behind on homework, you need to fix that too.